Thank you so much. So without further ado, let's start. So logging in Python, this talk is called Why, When, and How. I will try to deep dive into what kind of problems we have when it comes to logging, which is seemingly a very simple topic. I have an ask. So if someone could snap a picture of me while I'm doing this presentation and then airdrop it to me, I would very much appreciate it. Need it for my report later. All right. Come again? Airdrop or my email. Yeah, whatever will work. Thank you. Right, so a little bit about me. My name is Vagiz. I'm a software architect at Dynatrace. It's an observability and monitoring company. You can find me by my handle Vagiz Duseev on Twitter or LinkedIn, or through my email. In my free time, beside architectural work, I'm working on a language learning app called Lingo Cards. That's specifically currently tailored to English and Polish learning. And if you are learning a language with a tutor, please reach out to me. I'm desperately looking for alpha users. Also in my free time, I manage servers in several countries. I love to do bare hardware, and I know how to migrate from cloud back to actual hardware to save costs. But that's a bit unrelated to today's topic. So why logging is a problem at all? So first of all, it all starts very simple, right? We've all been there. We do some basic print statements. It's all fine, it's all nice, really good. What's next? Then it gets complicated. We want to add some formatting, etc., and we want to add some configuration to our logging. Maybe we share the same logging configuration between different projects or between different teams. We get even more overhead when we go to production because now we somehow need to manage these logs. Who is going to do that? DevOps? I don't think so. Then we finally meet some crucial incidents in production. That always happens. What happens when we have an incident? We need to investigate logs. How are we going to do that? Where are they even? Do we have logs for a certain date? How are we going to search them? And finally, when it comes to a large scale, these logs start to occupy a lot of space, and we have to think about retention, or God forbid, if we have to abide by compliance rules where we have to store these logs for 5 or 10 years if we are in financial industry or medical industry, that becomes a real headache. So let's start with the simplest examples. What I've been talking about, we've all been there. Back to university or school code, print statements, perfect. Let's take a look at a quick example. So I have here a very basic Python script which just executes a function in a loop. So let's see what it does. I'm just going to call it. And I swear to God it's going to work. Yeah. So this is what we are all familiar with. Just simple logging works nice. We don't need anything else. We are content with this. Next, we think, okay, those logs were pretty cool, right? But we didn't have anything about timestamp. Which event happened when? Okay, let's add a small timestamp, right? We have date, time, now. We are going to create our own logging function. We all did this someday back in the time. So let's see how that works. And of course, it's going to work really well because now we have a timestamp. By the way, all of these examples are going to be available on a GitHub repository. I will give a link to it later at the end of the presentation. So perfect. Now we have a timestamp with our logs. That's great. Maybe we want to add logging level information to that. Maybe we want to tackle a problem of multi-threading or multi-processing and indicate which thread ID this log line belongs to. Okay, that starts to become a little bit complicated. So maybe there is, maybe there is an already made solution, and of course there is one. It's provided by. Oh yeah, by the way, that was really nice. It's provided by a standard Python library called logging. So we take it out, we look at the documentation, we kind of scratch our head and think, why does it look like Java? And everyone asks this question at some point, like the API naming is inconsistent with Python standards and really resembles Java logging, because that's where it was copied from. So we do a basic logging with standard library, and we expect a nice output right away, but we probably won't get it. And here is why. Right here, I think I've messed up one of the examples. It was just a basic configuration which allows you to specify logging level, because by default the library only allows you to, by default the library only logs warning level and above it. So let's quickly fix that. That should be enough, I think, unless I missed something. Bracket. All right, let's take a look. That's example 3. Okay, so we get the logger name, which is root by default in the library. We get the logging level, but we don't get the timestamp. Crap, we need to do something about it. And we have to now add formatting to that. That's pretty simple. So we go and add formatting. It now outputs a proper format, at least we hope it does. We see that the formatting of time takes a format of locale, so the log format will depend on the locale of the system, which currently is not a problem, but might become one if we need to parse these logs later. What's next? Maybe there is a better library. So what if we take one of the most popular external libraries called Loguru, which provides almost everything out of the box. It gives you nice formatting and so on. We are very excited. Nice, let's try it. Loguru, of course, accomplishes this task which we dream standard library was able to accomplish, which is to output everything without additional configuration in a nice format. And it's true, yeah, it looks much better now. We can see that there is a properly formatted timestamp, there is a nice indentation of the logs, works really well. However, once we skip to the moment where we have multiple libraries in our project, and some of them have internal logging as well. This especially happens with production level web services, where we need to have some kind of web server. Let's say, for example, we use UVcorn, and we also need some error catching libraries such as Sentry, maybe. We might also connect to databases, maybe to Postgres, maybe we use something like Redis. All of these libraries, they have their own logging configured. And if we are using something like Loguru, it becomes really cumbersome to turn those logs off or change their formatting. So we are now in a situation where we have to maintain two different logging libraries, the standard Python library with its configuration and so on, and Loguru, or whatever other solution we chose. So in this example, number 6, we still use Loguru, but we turn off logging from some other module, maybe by Sentry, so it doesn't pollute our logs. Let's take a look at how that works. You can see that I have a module here, which is called some module. It just outputs a simple function, and I call it within my process data function. And let's see how that works. What are we going to get? So you see that now logs produced by Loguru, which we wrote, they look nice. But whatever was done by some other module, which we depend on and we don't want to change its source code, it's an external module, it does its job. It doesn't care that we use something else. And we can do that through Loguru, just as a note. But trust me, it's difficult. And you will write more boilerplate code than you wish you could. So yeah, of course we solve it with now having to manage both standard logging and Loguru, and now the logs from external module disappear. Okay, perfect. But what comes next? We can't just continue to log everything to the terminal. We need to preserve these logs if we want to read them, examine them, and so on. So we add a log file handler. So it's pretty easy to do in a standard logging library and in Loguru as well. We just add a log file, and of course it works well. It just writes everything to a log on our machine, whichever path we have specified. So in my case, it should write to a file called logfile.log. Right? Okay, I have no idea what I broke here, but yeah, let's say it is supposed to log to a log file. Yeah. So with log files, we need rotation, of course, because if we continuously log into the same file in production, this file is going to grow. We can't really like just copy it and then clear it because or delete it, because then the file handler will remain the same while our program is running, and it will continue to write into non-existing files. This happens both on Windows and Linux if done incorrectly. So we can add some log rotation in the code itself. Again, pretty simple, but then we might expect some questions from DevOps, because they come, or CSOPs, they come and ask, all right, but what if the program stops? Who is going to rotate these logs? Who is going to manage logs from multiple programs? What if developer forgets to add proper log rotation? How are we going to update a rotation config in a production environment? Do we have to change the code every time we want to make a change? What if the same log rotation code exists in multiple projects running on the same server? That becomes really, it already becomes a headache. So at this point, it's much better to switch to a solution, something like what is available on Linux. It's called logrotate, a very popular and very simple library which does log rotation for you seamlessly. So in this basic example, any kind of log written by your program, by your application to this directory will be rotated daily up to 7 days. The logs will be compressed by default, and it all goes, it's invisible and happens implicitly for your application. It just continues to write into the same log file. So that's usually where it used to stop in old systems. But now we've had an incident, for example, and we need to search through logs. And of course, our DevOps and SysOps guys, they have answers for that. They're saying, just grab it, dude. Just go to the server, here is a login. Don't you know how to use Linux terminal? Just Google it, it's a grep. And we want to investigate who is DDoSing our web server. Yeah, we need to check all the records for this specific log file. Very easy. But we have log rotation, and some of the logs are already compressed. So no problem. We get an answer from DevOps. Just uncompress whatever log files you have, and then grab those. There are multiple ways to do that. That's one of the examples, of course. So we at this point we usually have to write some kind of bash script which goes through all the last 7 days of logs, uncompresses them or whatever, does some search and so on. So we are starting to build a solution for a problem which is already solved. And I'm not even talking about some complex regex expressions. So we all know that grep is probably not the most perfect regex supporter, especially on some systems. And our product managers or product owners, they start to ask, okay, can we not do it on a server? Can we have some nice UI maybe? What if we want to aggregate by date, or maybe we want to count how many invocations of our web service happen from this specific IP address? Our Linux gurus, of course, have answer for that. Yeah, you can use AWK, you can count number of lines, it's all doable in the terminal, but our product owners, they don't want to learn that, so they want a nice solution, and there are solutions for that. We can use something like Elasticsearch, Stack, Splunk, Greylog. There are literally dozens of solutions specifically built for that purpose. All of them, unfortunately, are not ideal, and some of them are tailored for a specific use case. Like Elastic, for instance, wasn't built for log storage. So there are strong sides and weak sides to each of those. In my examples today, I'm going to use OpenSearch, which is just a fork of Elastic from Amazon. And I've built a little project of mine, which is a handler for Python, which logs from your Python application, sends the logs from your Python application directly to OpenSearch. Very small project. It's listed as a recommended one in official OpenSearch page. And here is the way it works. You have an OpenSearch instance up and running. In my case, it's currently running on my local host machine. You configure a handler with very simple set of config options. By the way, most of these are set to sane conditions by default for an easy start. But you can pretty much decipher what happens here just from the configuration log. I specify some credentials. I want to use encryption. I don't care about certificate verification and so on and so on. The next step would be to actually add this handler to, this is what I did wrong in that example. It's not add, it's add handler. You add this handler, and in this example, we are going to send logs both to OpenSearch for indexation, and we are going to continue to stream them to standard output in a terminal. And the process data function is going to stay the same. So let's take a look at how that works. It's example number 9. So this is the code I was showing you on slides. I have an OpenSearch instance running on my local host machine. And at the moment it's empty. There is nothing on this search instance. And let's create some logs. So because we didn't specify any kind of formatting for the standard Python library, it outputs everything as is, nothing in terms of logging level, or which logger or which thread is added to this information. But it already sends these logs directly thanks to this little library to OpenSearch. Let's go ahead and check what is happening with the OpenSearch. We are going to click Discover, and we need to create our index pattern, and we can see that some logs with the prefix mylogs are already ingested and are detected by OpenSearch. That's because we specified index name prefix in our configuration. So I'm gonna go ahead and create an index pattern with this prefix. It asks me to choose a timestamp. You have noticed that the log messages do not have timestamp in the terminal, and they do not have timestamp when they are sent to OpenSearch. So what happens is that library adds this timestamp by default. If the library doesn't do that, OpenSearch will do it itself. So it's going to add a timestamp to your incoming message. I'm clicking create index, and now when I go to discover page, I can see the log messages coming in. All right, so that's already pretty nice for our use case, because what happens here is that for each log message that was sent to OpenSearch, this log message was indexed and parsed by OpenSearch inefficiently. Let's note that, but nevertheless, it was even ingested, enriched with some information added by default by the library, such as host ID, from which IP address it was done. So this information was added by the library itself, and there is a message from the application. So this is the actual data. And because of the fact that OpenSearch is a full-fledged indexing solution, it tokenizes every input, it breaks it down and builds an inverse index and allows us to do a pretty complicated full-text search. So in terms of capabilities, if you've ever worked with Postgres full-text search, what Elastic provides, or OpenSearch in this case, is even more complicated and allows for more complicated use cases. Now, that's all fun and games until we understand that when this solution works, what it does is it sends logs directly from each application, each instance of our application, to Elasticsearch. So nothing protects us from the fact that when an application crashed, who is going to send these logs? Who is going to send the crash stack trace, for example? We are just going to lose it forever, and we are not going to catch whatever happened. So a solution to that would be to use whatever environment is provided to us. Usually it's some kind of containerized environment, to use that as a reliable solution to collect the logs and then send them to whatever indexing solution we have. So in case of Docker, it provides some standard drivers for logging, and it has integrations with most popular solution. For instance, Docker has integration with FileBit, with FluentD, directly with Elasticsearch. You can even log files to AWS CloudWatch, and all of that is already done. You just need to install it, configure it. It works pretty well. So in our case, we are going to go with even more production-ready approach. We want to control every aspect of our logging solution. We want to turn off unnecessary libraries. We want to control formatting, all the stuff, maybe even dynamically we want to do that. We want to rely on Docker Daemon in this case. So what's going to happen is that we are going to write logs simply directly to the standard output, to the terminal. And what Docker does under the hood is that it writes these logs to a file in a volume, which is then provided to whatever driver, logging driver is available or whichever we installed. And that guarantees that if our application crashes or something happens with network, the logs are going to be saved by Docker Daemon and then are going to be sent by the driver. We are also going to use fluentd for log collection. There is nothing special about it, just personal preference due to simplicity and speed mostly. Yeah, let's take a look at how that works. It's going to be a slightly bigger example. So I guess it's easier to start with an app itself. I have a standard Python logger, but I'm going to configure it using a dict. So this is actually a current up-to-date and recommended format of configuring logging in Python. You can do it with a ini file, but dict is a recommended approach. It supports full syntax of standard Python logging configuration, and you can see that in this example, I'm disabling any kind of loggers which were pre-configured. So at the point where I'm going to call this function, anything that was configured in a current environment, in a current Python process, is going to be turned off. I specify a formatter. I'm going to use a small library called Python JSON logger in order to convert anything I log into a valid JSON. So that allows me to log entire objects and so on, because once it is sent as a JSON to OpenSearch, OpenSearch can then parse it field by field and do not treat it, instead of treating it as a single string. That's really important for indexing performance and for further tasks such as aggregation. I'm configuring a single handler, so logging directly to a terminal into the std error stream with a formatter I configured above. And I've turned off or on many loggers for some modules I have in my big project, and just setting, for example, a default logging level for the root handler, root logger actually. Why that can be important? That's because every single logger you add in your project, for example, doing something like this line, is inheriting its properties from the root logger, and then you change them. If you don't change them, they are just going to be exactly as a root logger. And the actual code is pretty much the same as in every other example. So I'm going to remove this sleep here. I had it because if I hadn't started OpenSearch before, the application would start logging things right away. fluentd is going to start collecting them right away, and there might be a delay before we see them, so I've just added it for convenience. But since OpenSearch and fluentd are already started in my environment, we have 3 containers running here. It's OpenSearch itself, OpenSearch dashboard, and the fluentd as log collection. The way it all ties together is through a Docker Compose. So I have a service for my application, and you can see that I specified Docker driver for logging, and in this case it's fluentd. I specified a couple of interesting options, such as do not wait for fluentd to get up and can start logging right away. Let fluentd pick it up later. Not every Docker driver for logging provides such options, so it's pretty useful. And I have OpenSearch and its dashboard as well, and of course fluentd container itself, which has a config which looks like that. It just takes any logs which are sent to it from Docker, and it applies the JSON formatting. In any case, if you send it as a JSON, if you send it as a string, it's going to be converted to JSON anyway. So with that in mind, let's try to launch it. So the small program which we took a look at is running. It's reporting its logs, and the index to which these logs are reported is going to be called example log. So this is a prefix which is going to be added by FluentD when it picks up all the logs which are sent to it from Docker daemon, and it's going to add this prefix when it sends the logs to OpenSearch. It also batches all the logs, so not to pollute network too much, and it flushes the log batch every 3 seconds. So you can of course change this configuration depending on your needs. Let's take a look at what happens right now. We will need to configure another index pattern. Let's create one. We can already see that logs are there, which is a really good sign. So as usual, we are going to choose timestamp, and there we are. Now if I go to Discover and switch to the logs sent from FluentD, this is how it looks. You can see that every single field was parsed as JSON, and that allows us to do more complex queries for searching for analysis in OpenSearch, which is really beneficial for some kind of analytics later or for investigations. So, as I said, at this point, it's a big brain time. Yeah, works really well. This is something I've been using in many production systems, and in Kubernetes it works as well. It's a really good approach. You can choose any part of this system, so you can replace FluentD with something else. You can rely on some products provided to Kubernetes. Usually they are deployed through operators and running like daemons in Kubernetes environment. You can replace the destination, so in my case it's OpenSearch right here, but it could be anything. The company I'm working for, Dynatrace, also provides a solution for log collection, and so on and so on. So this is pretty much production ready system, but not ideal. So one of the problems I've had throughout the years with all of these systems is that there is always some caveat to each of them. Either if it's cloud-only solution or something like that, or even something like Splunk, it's super expensive. So you can imagine prices in the range of like, I want to store a terabyte of logs with a 30-day retention, and it's going to be right away 100 or 1,000 USD per month. So like, this is normal, totally normal for the industry at the moment, especially when it comes to enterprise pricing. So for a normal user, even for a small startup, to create an environment where you have these logs which you can investigate and store them and retain them, it's a pretty huge headache. So I've been thinking what would be a perfect solution to that, and thankfully some other newcomers to the market are implementing an approach close to that. So it needs to be open source, because there are many closed source systems which are close to perfect, but you cannot run them locally without a license or even running locally at all. So it needs to be open source for a widespread adoption. It needs to store many kinds of observability data, such as metrics, traces, and logs. If you think about it and convert it to sort of a tuple where there is a timestamp, there are some attributes, and maybe there is a value, all of these metrics, logs, and and traces are the same actually. So the system capable of storing metrics or logs properly should, in theory, be capable of handling all of them well. Such system, in my opinion, should be tailored to a lot of writing and very little reading, actually, because we care about just writing the logs. We are not even sure if we are going to need them, but we want to preserve them. And some alerting on the flight would be nice. So if we set up some kind of patterns, let's say a certain error appears in the logs or a certain dynamic, like last 7, for example, log entries from a certain service indicate a specific problem, we want to get an alert. So that must be part of the system. Time series, so that's a very interesting part. So all data must have a time series, so it's a time series based data. If you think about it, even Elasticsearch wasn't built for time series initially, it's built for text indexing. So time series and log applicable solution is something it was later on applied to, but it wasn't built for that. And many other solutions, such as column-based databases, for example, Cassandra or ClickHouse, they weren't built for time series data as well. And that means that some architectural decisions, design decisions, were made early on with these systems, which make them less perfect for the case of monitoring. Of course, such solution must be horizontally scalable, and it shouldn't require running instances. I guess this is the most important. With almost every single solution on the market right now, you need to have something running. And we all know that EC2 instances are expensive as hell, or we have to maintain our own servers and so on. But in my opinion, we shouldn't have anything running actually to collect logs. There should be some kind of data dump where we just continue to write them, but we don't need to query them every second. So there is no really a purpose. It's not a real database for something powerful to be running all the time. So this is why Postgres tailored for metric for time series based data, or Cassandra, or ClickHouse, or Splunk. None of that satisfies this criteria, and this is what makes it expensive. It's not the storage, actually. It's the cost of running these instances 24/7. As with Elastic, I think that such solutions should not rely on a schema defined upfront, because that just stales all the development. We should be able to write whatever, and it should adapt to our needs. And one other thing, it should be agnostic to underlying storage, I think. I believe that it doesn't really matter whether we use object storage or something like Ceph, or we use hard drives. It shouldn't really matter. We are just storing things in some kind of format, maybe Parquet, like a columnar-based format, really popular and simple. But that should be agnostic to underlying storage, because there are solutions out there, such as Axiom, for example, which rely on object storage. So I don't think that should be the case. Unfortunately, there is no such system in the world, so I beg you, if someone starts building something like that, please let me know. I'm going to help maybe join such development. Right, so that concludes my presentation. You can find all the examples, full code with the presentation in this Python repository. There's going to be a QR code which links to this repository. Please reach out to me on Twitter or LinkedIn if you have any questions. My email is always, you are always welcome to reach out. And thank you for your attention. If you have any questions, please let me know.
Okay, there are some questions. Is Loguru compatible with OpenSearch?
Haven't checked recently. Let's do that. The thing about OpenSearch is it's backwards compatible with Elastic, at least at the moment. Yeah, I'm not seeing like a quick answer. So probably second or third page of Google. But at the moment, at least for the next year or so, maybe two, whatever is compatible with Elastic is going to be compatible with OpenSearch. The gap is going to grow, of course, but for the moment we are fine. Later on, I believe there are going to be more libraries for all the different solutions out there.
Next question. Catching errors to do some logging, then raising anyway. Yay or nay?
Totally yay. Totally yay. So that's what I do myself. I catch, if there is an error in try catch statement, I log it. If I think it's something I want to see later on, I log it. Then I re-raise it or whatever. Maybe I transform it to another exception, and I let it crash. So in my personal opinion, it's if you have an exception which is supposed to crash your application, let it crash. Let the other systems handle whatever is wrong. So restart your application or decide to do something else. There is entire ecosystem built around that approach, and it's built into Docker and Kubernetes. So that's what your application is supposed to do. And when it crashes or it throws an exception, there are solutions to handle that really well, such as Sentry. It's going to catch your exception, it's going to catch complete stack trace and so on. Works really nice, and I recommend such approach, so totally yay.
Is it possible to configure Loguru as a handler in standard Python logging library to avoid hacking libraries in order to use Loguru?
Not sure. It's been a couple years since I worked with Loguru on a couple of large projects, so probably, maybe, not sure.
Okay, and there's a question, and I think there's a verb missing in it. Have you ever?
Have you ever used a logging pattern when you log start and end of event? In Java, it's called MDC, Mapped Diagnostic Context. Then Java keeps coming up with new solutions, yeah? For my use, it's an overkill. It is an overkill. You shouldn't use logging to capture an end, and a start and an end of the event. I mean, it used to be like that approximately 15 years ago, but it shouldn't be like that anymore. That's what traces are for. That's what OpenTelemetry is for. You create, in Python, it looks like a with statement usually. You surround a certain context with a span, and you use something like OpenTelemetry and OpenTelemetry catcher, collector, sorry, and then later visualization of these traces to see exact spans, and you can see like a diagram of how much certain event took, or it's almost like a heat map. So definitely, if you have to, maybe you need to do that. But at least in 2023, we can use OpenTelemetry easily for that in Python.
And those are all the questions. So thank you for your talk.
Thanks.